In the solar system, the Earth has a special relationship with the Sun and the Moon. The Earth revolves around the Sun, and the Moon revolves around the Earth. The Earth also rotates on its axis. These motions of the Earth cause days and nights, seasons, tides, eclipses, etc. 1. Day and night. When the Earth rotates on its own axis, only one portion of the Earth's surface comes into the rays of the Sun and experiences daylight. The other portion, which is away from the Sun rays, will be in darkness. As the Earth rotates from west to east, every part of the Earth's surface will be brought under the Sun at some time or other. A part of the Earth's surface that emerges from darkness into the Sun's rays experiences sunrise. Later, when it is gradually obscures from the Sun, is in fact stationary, and it is the Earth which rotates. The illusion is exactly the same as when we travel in a fast-moving train. The trees and houses around us appear to move and we feel that the train is stationary. 2. The Earth's revolution. When the Earth revolves round the Sun, it spins on an elliptical orbit, and one complete revolution takes 365 days or a year. As it is not possible to show a quarter of a day in the calendar, a normal year is taken to be 365 days, and an extra day is added every 4 years as a leap year. The Earth rotates once in about 24 hours with respect to the Sun, and once every 23 hours 56 minutes and 4 seconds with respect to the stars. This is the reason why the stars rise 4 minutes early every next day. Earth's rotation is slowing slightly with time, thus, a day was shorter in the past. This is due to the tidal effects the Moon has on Earth's rotation. Atomic clocks show that a modern day is longer by about 1.7 milliseconds than a century ago. Leap seconds are used to synchronize atomic clock. 3. Varying lengths of day and night. The axis of the Earth is inclined to the plane of the ecliptic, the plane in which the Earth orbits round the Sun, at an angle of 66 degrees, giving rise to different seasons and varying lengths of day and night. If the axis were perpendicular to this plane, all parts of the globe would have equal days and night at all times of the year, but we know this is not so. In the hemisphere in winter, as we go northwards, the hours of darkness steadily increase. At the Arctic Circle, 66 degrees, the sun never rises, and there is darkness for the whole day in midwinter on the 22nd of December. Beyond the Arctic Circle, the number of days with complete darkness increases, until we reach the North Pole, 90 degrees north, when half the year will have darkness. In the summer, June, conditions are exactly reversed. Daylight increases as we go polewards. At the Arctic Circle, the sun never sets at midsummer, the 21st of June, and there is a complete 24-hour period of continuous daylight. In summer, the region north of the Arctic Circle is popularly referred to as Land of the Midnight Sun. At the North Pole, there will be 6 months of continuous daylight. In the southern hemisphere, the same process takes place, except that the conditions are reversed. When it is summer in the northern hemisphere, the southern conditions will experience winter. Midsummer at the North Pole will be midwinter at the South Pole. 4. The altitude of the midday sun. In the course of a year, the Earth's revolution round the Sun with its axis inclined at 66 to the plane of the ecliptic changes the apparent altitude of the midday sun. The Sun is vertically overhead at the equator on 2 days each year. These are usually the 21st of March and the 21st of September, though the date changes because a year is not exactly 365 days. These 2 days are termed equinoxes, meaning equal nights, because on these 2 days all parts of the world have equal days and nights. After the March equinox, the Sun appears to move north and is vertically overhead at the Tropic of Cancer, 23 degrees north, on about the 21st of June. This is known as the June or summer solstice, when the northern hemisphere will have its longest day and shortest night. By about the 22nd of December, the Sun will be overhead at the Tropic of Capricorn, 23 degrees south. This is the winter solstice, when the southern hemisphere will have its longest day and shortest night. The tropics thus marks the limits of the overhead sun, for beyond these, the sun is never overhead at any time of the year. Such regions are marked by distinct seasonal changes: spring, summer, autumn and winter. Beyond the Arctic Circle, 66 degrees north, and the Antarctic Circle, 66 degrees south, where darkness lasts for 6 months and daylight is continuous for the remaining half of the year, it is always cold, for even during the short summer the sun is never high in the sky. Within the tropics, as the midday sun varies very little from its vertical position at noon daily, the 4 seasons are almost equal all the year round. 5. Seasonal changes and their effects on temperature. Summer is usually associated with much heat and brightness, and winter with cold and darkness. Why should this be so? In summer, the sun is higher in the sky than in winter. When the sun is overhead, its rays fall almost vertically on the earth, concentrating its heat on a small area. Temperature therefore rises and summer are always warm. In winter, the oblique rays of the sun come through the atmosphere less directly and have much of their heat absorbed by atmospheric impurities and water vapor. The sun's rays fall faintly and spread over a great area. There is thus little heat, and temperatures remain low. In addition, days are longer than nights in summer and more heat is received over the longer daylight duration. Nights are shorter and less heat is lost. There is a net gain in total heat received and temperature rise in summer. Shorter days and longer nights in winter account for the reverse effects. 6. Dawn and twilight. The brief period between sunrise and full daylight is called dawn, and that between sunset and complete darkness is termed twilight. This is caused by the fact that during the period the dawn and twilight the earth receives diffused or refracted light from the sun whilst it is still below the horizon. Since the sun rises and sets in a vertical path at the equator, the period during which refracted light is received is short. But in temperate latitudes, the sun rises and sets in an oblique path and the period of refracted light is longer. It is much longer still at the poles, so that the winter darkness is really only twilight most of the time. 7. Eclipse. An eclipse occurs when the sun, the earth and the moon are in a straight line in the plane of ecliptic. When the earth obstructs the rays of the sun from reaching the face of the moon gets eclipsed. When the moon hides the face of the sun, then it is an eclipse of the sun. At any time the sun is able to light only half of the earth's surface which is facing the sun. The other half, which is turned away from the sun, is in darkness. 7.1. Lunar eclipse. A lunar eclipse will occur only when the sun, the earth and the moon are in a straight line, and the earth lies between the sun and the moon. This is possible on a full moon day. But a lunar eclipse does not occur on every full moon day, as these three bodies have to be in the plane of ecliptic. A. If the moon is exactly in the plane of ecliptic, a total lunar eclipse will occur. B. If the moon is close to the plane of ecliptic, a partial lunar eclipse will occur. C. If the moon is far above or far below the plane of ecliptic, no eclipse will occur. 7.2. Solar eclipse. A solar eclipse will occur only when the sun, the earth and the moon are in a straight line, and the moon lies between the sun and the earth. This is possible on a new moon day. But the solar eclipse does not occur on every new moon day, as these three bodies have to be in the plane of ecliptic. A. If the moon is exactly in the plane of ecliptic, a total solar eclipse will occur. B. If the moon is close to the plane of ecliptic, a partial solar eclipse will occur. C. If the moon is far above or far below the plane of ecliptic, no eclipse will occur. The diamond ring effect is a visual phenomenon that occurs during a total solar eclipse. It is seen from Earth when standing in the umbra of the moon's shadow, and occurs as a part of Baily's beads. Baily's beads are glimmers of the sun's brilliant surface, the photosphere, which shine as dots of light around the disk of the lunar shadow. When only one bead remains, momentarily, the view of the eclipse resembles a diamond ring. The ring is produced as the sun's less bright corona layer and other upper atmospheric structures remain dimly visible as a solid ring, while a dazzling dot of the photosphere shines at the edge.